Okay. Okay, we could start this final session of the MedGold Living Lab, and before starting, a brief recap of the previous session in the Living Lab. Is 1 month before we have had the first session on Monday, 25th of May, and now we are in the final session. Let me remark the repository where you can find all the material of the Living Lab. In the first session, as you remember, we have had a general overview of the climate service at European level, and then we have had the presentation by our problem holders for the three problems presented for wine sector, for durum wheat pasta sector, and coffee. Sorry, and then we have had a lot of space for the team works, and we have had a lot of works done from the three teams. And in the second session, we have started going depth to the methodological framework adopted in MedGold project and here reproduced in the Living Lab. The first step is assessing the user need, and we have had a lot of very comprehensive presentation by Marta Bruno Soares about the assessing user needs and co-development and co-producing pilot climate service. And in the third session, we go to the second step of the methodological framework. It is the co-development of the service, and we have had a lot of showcase of very interesting example of climate service for the agricultural sector, and some example from the MedGold project, and an overall overview on how we can find and how we can access climate data to develop climate service. Finally, the session of the last week, we go to the third step of the methodological framework, so testing the service, and we have had a very interesting presentation by Marta Terrado, BSc, about all the communication and visualization issue related to climate service, and then we go to the quality assessment of pilot service in MedGold by Sandro, and even the testing phase of the MedGold pilot service. Here I have reported a slide about the testing phase in MedGold, about the scalability, replicability, and today we'll come back to this kind of concept during our presentation. And now today is the final step of the methodological framework, the assessment of the added value for the decision-making process in the for climate service. And we have had three very important presentations today by Natalie Suckall about the evaluation of climate service, and then we go to the implementation of the climate service and the upscaling of climate service. Finally, we'll have the three presentation by the three teams. We have had some small readjustment of the agenda for today. Very sorry about this, but it is for meeting the needs of our stakeholders, because they are very busy and they cannot attend in the morning session, and so we should we should have readjust all the program. And I would like to remark that this is a very common issue in the climate service business, because for sure stakeholders are very busy and they have a very overcrowded agenda, and so we in the climate service activity we have to be very flexible, and we have to be very quickly to reply to the user needs, also in the construction of an agenda of an event. So this is a good example of the flexibility needed in climate service. Sorry to being so long, and that's all from my side.
Thanks, Alessandro. I will now share the rest of the session this morning, and as Alessandro mentioned, we have three really interesting presentations, and I will introduce each of the presenters as they come into the floor to present. And the first one is Natalie Suckall. She has a background in climate and development and has conducted field research across Africa and Asia, has worked on various projects that examine the impact of climate change on poor communities in predominantly agriculture-based societies. And she's now working in the Asia Regional Resilience to Climate Change program, where she examines the socioeconomic benefits of weather and climate services and interventions in the region. So without further ado, I'll pass on to Natalie, who will be telling us a bit more about how to actually evaluate climate services.
Thanks, Marta. So this is the first time I've used Amazon Chime, so I'm going to try and share my screen now on my slides. So sorry, just bear with me whilst I figure all this out. So if I do share screen, and then I do that. Hang on.
Yeah,
no, I can't.
It's working.
Yes.
Everybody's video pictures are over the little icon where I need to make it a full screen.
You can move the...
I can move you all over there, can't I? There you go.
Video, there's like a little square with an arrow. You can kind of click that and it will move the image. Yeah.
So can you can see that, right?
Yes. And you have a bit longer, actually, so it's up to you. I think we allocated half an hour, but you can allow a bit more time for questions as well, so it's up to you.
Okay, I was planning to speak for about 15 minutes and about 15 minutes of questions, at which point I might also invite Marta to be part of the questions. I'm sorry, Marta.
No, that's fine. Okay.
Anyway, hi. My name's Natalie Suckall. I'm a research fellow at the University of Leeds, and I work on the Asia Regional Resilience to a Changing Climate, or ARRCC programme, and it's a large Met Office funded programme related to weather and climate services. And I'll talk about that in just a minute to set the context for the rest of this talk, which is about evaluating weather and climate services. So very briefly, let me just give a bit more background then to ARRCC, the ARRCC programme, so you've got a better understanding of where I'm coming from. Are these video, can you see people's faces? Are they in the way? Should I click those off? Is it obscuring the slide?
No, that's absolutely fine. It's up to us to move the videos around. So
I understand. Okay.
Yeah.
Yes. So just a bit more background to ARRCC, so you can understand where I'm coming from and the kind of things that inform my thinking here. So as I said, ARRCC is the Asia Regional Resilience to a Changing Climate, and it's a 4-year Met Office funded programme. And in the middle of this slide is the aim of ARRCC, which is to increase resilience to weather and climate risks through enhanced regional coordination, capacity and tools for decision-driven weather and climate services. And we focus on South Asia. There's a map in the top right corner of the screen there. We primarily work in Afghanistan, Bangladesh, Pakistan and Nepal. Moving over to the left of this slide, there are 4 work packages within ARRCC, and the first 3 broadly relate to different temporal scales. So work package 1 looks at weather, and in particular impact-based weather forecasts. So these also forecast the social and economic impact of predicted weather. So we can see which sectors or locations will be most affected by an event and potentially where support should be mobilised to in advance of that event. Work package 2 looks at seasonal climate outlooks. Work package 3 looks at future climate projections. And then sitting at the bottom there is work package 4, which I work on with Marta, which examines the value that can be generated from the type of activities that we promote within ARRCC. Oh, sorry, I'm going the wrong way here. So to do this, Marta and I are about to evaluate 4 case studies of different weather and climate services within ARRCC. And these are firstly the benefits of developing impact-based forecasting on disaster risk reduction in Bangladesh and Nepal. Secondly, we'll be examining the flow of information from regional from regional to national level, and that's seasonal information, and how that might improve food security outcomes in Bangladesh and Nepal. And then we'll be evaluating a national level assessment of the impacts of climate changes and climate projections on food security in Afghanistan and Nepal. And fourthly, we'll be working with the Pakistan Meteorological Department, possibly to examine the impact of their agri-met services on subsistence farmers. So why do this? What's the point? Why evaluate? Why are we doing all this evaluation? Why is it important? Well, firstly, it's really important to justify investment in the provision and delivery of weather and climate information. And I read a study yesterday, I think, that claimed that in 2015, we spent about $56 billion on weather and climate services. So that's obviously a huge amount of money. And we want to know if that investment will pay off. Is it working? Is it worth it? Do we keep pumping billions of dollars into this? Related to that, but on a more local level, is the need for national governments to effectively spend scarce public resources. So again, national governments here have to demonstrate that the benefits of the climate services, weather and climate services, outweigh the costs, and especially for interventions or services that are funded by taxpayers. Evaluations can also help tailor a service to an end user. So, for example, an evaluation might reveal that as information is passed from a producer to an end user, it loses meaning, or it isn't reaching everyone that it intended to. Something's happening to that information, and it's not having the maximum impact that it could, and evaluation can help pick that up. And it can also be used to justify pricing for bespoke products like seasonal forecasts. So whoever's using that forecast would be more likely to pay for it potentially if they have an idea of the benefits involved. So in the next 10 minutes or so, I just want to give an overview of some of the main methods that we use in evaluations. And I'm about to go into some of these in more detail, but very briefly, they are contingent valuation, which directly asks people how much they'd be willing to pay for a service. Revealed preferences, where market data is used to see exactly how much people spend on a service, but there's very few examples of those type of evaluations out there. Economic decision modelling, where models are used to examine if people behave differently if they have weather and climate information and if they don't. Avoided costs, which is about determining how information could contribute to avoided asset losses and avoided mortality or lives saved. Benefit transfer, where the findings of one study are applied to a different case, the case that you're looking at where perhaps data doesn't exist. And finally, participatory approaches that use methods like interviews and focus groups to get a really deep qualitative insight into perceived benefits. And somewhere about now, I should probably explain that with the exception of participatory approaches, these are all economic methods. And I'm not an economist, I'm a social scientist. So my explanation of these methods are with my social science hat on, but I think that's fine. So I'm going to focus on these three: contingent valuation, avoided costs, and participatory approaches. So the first thing, contingent valuation. So this estimates the value that a person places on a good by asking them directly. And that's usually done through surveys with end users or potential end users like farmers. And they're asked about their willingness to pay for a service or their willingness to accept compensation for giving up that service. And I think the best way to explain this is through an example, which I have here. So this is a really great case study of the economic value of seasonal climate forecasts for maize farmers in Benin, in West Africa. And here a team of researchers from universities in Benin and Ghana spoke with maize farmers, 354 maize farmers. They did surveys with them, and they asked them what type of seasonal climate forecasts the farmers wanted, how they wanted to receive the information, and critically, how much they'd be willing to pay for it. And for this group of farmers in Benin, they wanted a forecast about 1 to 2 months before the rains came, so they could plan well in advance about what to plant and when to plant it. And they wanted to receive information through the radio, as well as through extension officers from government who come into the village with details of the rains and about the forecast. And it turns out that 82% of the farmers surveyed would pay for this service, and they'd pay about $19 each year for it, or each season for it. And I think this is a really is really interesting, because with this type of information, you can make a really clear evidence-based case for implementing a very specific type of seasonal climate forecast that's been tailored to these farmers' needs, and you know how much they'd be willing to pay for this as well. So contingent valuation studies can be really useful. They can reveal a lot of good data, good information, but there's also a lot of debate around their use as well. And one of the key issues is the idea that contingent valuation only gives a potential insight into a potential value rather than an actual value, because no attempt is made to actually show if forecasts are used in the end. So farmers might say they're willing to pay however many dollars a year for information, but whether they actually do that in the end isn't part of the contingent valuation study. But other methods can be used to follow up, to see if farmers are using that. And completely related to that point are other concerns about how valid and reliable those results might be. So, for example, results could be affected by a hypothetical bias where respondents' stated behaviour is different to their actual behaviour. So, for example, respondents tend to overstate their economic valuation of a good by about 2 to 3 times. But to a large extent, I think these limitations can be overcome with careful study design and potentially follow-up surveys and interviews as well. So they're just something to be aware of rather than a barrier to carrying out that type of study. Okay, moving on now to avoided costs. So an avoided cost assessment would evaluate the benefits of improved weather and climate information by determining how the information contributes to avoided asset losses and avoided mortality or lives saved. And again, I think the best way to explain this is through an example, which I have here. So this was a study commissioned by the World Bank, and they wanted to know what losses could have been avoided in relation to the 2007 Cyclone Sidr in Bangladesh if a numeric early warning system had been in place. So just to give a bit of background about this, about Cyclone Sidr, it was a huge cyclone that hit Bangladesh in 2007, and it caused the loss of about 3,500 lives and caused about $2 billion worth of damage. So it's a really big deal. And Bangladesh already had an early warning system in place at the time of Sidr to alert people to impending storms and cyclones. And that likely saved lots of lives and that helped reduce asset losses. So because of that early warning system, around 1.5 million at-risk people fled to cyclone shelters, like the one at the bottom here, at the bottom of the screen there. But with Sidr, the highest evacuation warning was only given 27 hours before the storm hit. So people didn't have that long to prepare to go to cyclone shelters and make the preparations that they needed to. And a numeric early warning system could have extended this lead time or warning by about 5 days. So that would have given people much more chance to prepare. And it could have more accurately identified areas at risk of heavy rainfall and strong wind as well. So you know if you're in an area that you really have to leave. And the World Bank estimate that if this system had have been in place at the time of Sidr, people could have done early harvesting of some crops and fish and shrimp. They could have moved their household possessions, their agricultural equipment, fishing equipment, livestock, furniture, so on and so on and so on. And they could have avoided around $80 million worth of damage, and that doesn't include lives lost. So to put that into context, for every $1 invested in this early warning system, this numeric early warning system, there would be a return of around $40.85 in benefits. So I think this is a really interesting example because it shows clear evidence of the potential for benefits to outweigh costs. So again, as with all methods, that there are limitations. And one of the criticisms of the avoided cost assessment is that it doesn't capture the use of climate information and weather information to improve things like production or income. So, for example, it doesn't reveal details of how a farmer might deal with climate variability. So it doesn't give you a complete estimate of the benefits from acting on climate information or weather information. But that's fine depending on what you want to know and what you're trying to evaluate. And this kind of method can also be used in conjunction with other methods depending on what you're trying to assess. Okay, so my final method is our participatory methods. And these assess the perceived impact of weather and climate information on decision-making and livelihoods. And this is about perceptions, because this type of evaluation engages with individuals to deeply and qualitatively explore things from their point of view about what works and what doesn't and who for and so on. There's no single methodological approach to do this, to assess value using participatory methods, but some common tools would include interviews and focus groups and surveys, usually with end users, because it's from their point of view about what works for them. So again, another example, and a really great example, I think, is the participatory assessment of India's Agro-Meteorological Advisory Service. And this is one of the largest agri-met services or agri-met information programs in the world. And weather bulletins are tailored for farmers. In India, they're sent out over radio and TV and through district level advisors who go into the village and discuss with farmers. And the researchers here wanted to see if people were using that information and how the service could be improved. So they did interviews and focus groups with 490 farmers, and they got their perspective on how they received information and how they used it, perceptions in gaps in provision, and their suggestions for improvement as well. And one of the really important findings here was that 85% of men were aware of the service, compared with just 55% of women. And actually that was 11% of women in some regions. So men were getting this information and were aware of it, and women weren't. And men were really happy to receive the information through the TV and the radio, but women didn't want the information like that. And that's because they said they just didn't have time in the day to sit and listen to the radio and watch TV. They were out farming or doing what their household tasks that they had to do. So they didn't want the information that way. They prefer to get the information through a variety of means, including text messages, SMS messages, and advisors going into the village. And I think that's particularly important because women actually said they found the information more useful than men once they got the information, potentially because it was tailored to the kind of farming that they were doing. So for me, this really highlights the importance of understanding how things work on the ground and what could be improved from the point of view of the end user. And especially if you want to ensure that the information that you're providing has maximum impact, to include all of those perspectives from people on the ground. So again, limitations, and the key one here is probably around generalizability. So to what extent do the findings here or in the study you're doing apply to other communities or to different contexts? And how closely does the location of or the context of your study match other places? And I don't think it needs to be a problem, rather something that's reflected on. So to be aware that your findings might not apply everywhere in every context, and it can be quite specific. So my summary slide then, in summary, there's lots of ways to evaluate depending on what you want to know. All of them have limitations, all of them have advantages and disadvantages. There's a good but massive WMO 2015 report, which I have a link to here with more of those, with more details of some of the things that I've been speaking about in that report. There's also a report that Marta and I produced based on this, which is much shorter and probably more accessible. I'm not sure if that's available yet, but potentially we could make that available, which kind of distills some of those methods down into kind of a more accessible format. I just also wanted to make the point that at the moment, valuations aren't that common, especially in national Met services, but that might soon change. And one of the reasons for that is the GFCS, the Global Framework for Climate Services, in 2017, in their midterm review, called for a greater focus on evaluation. And they said that quite a lot, or many of the successes that we could potentially attribute to weather and climate services are going unnoticed because there's no formal recording process. and there still isn't a formal recording process, but people are becoming more aware of the need to evaluate and the need to highlight all of these successes. So potentially in the future, evaluations will become a more common thing. And I think that's my last slide. That was my last slide. Thank you, everybody.
Thank you, Natalie. That was really interesting, but I'm biased, of course. So I now open the floor to any questions that people might have, if there are any questions. Or was the presentation super clear?
This is Bala. I have a very simple question. What do farmers from developing countries think about climate forecasts? So I see that they have started using weather forecasts these days, but given a long-term forecast like in seasonal timescale, do they appreciate it, or do you think that they can take action based on such seasonal forecasts? And because in developing countries, the farmers are very much it's too risky for them to to do farming based on a forecast which could go wrong, and then
So Bala, is your question about if farmers in least developed countries find information like seasonal forecasts useful in its own, or if a level of tailoring and refinement of the information provided is needed?
Mm-hmm.
Okay. Do you want to answer, Natalie, or?
Yeah, I'll give it a go. So it's my understanding from what I know from speaking to people who do those local level evaluations with farmers, that farmers are generally quite perceptive or quite welcoming of seasonal forecasts. And I think there's a debate at the moment in the literature, in the community, about to what extent we use local level knowledge and embed that and build that into seasonal forecasts as well. So I guess there's a debate between sort of this top-down seasonal forecast coming from the producers of the information, and then somewhere that meets with local farmers, and what's the scope or the potential for kind of building these local levels perspectives into seasonal forecasts. So that's a debate in the literature, or in the community, which I'm not part of that debate. I don't do those local level assessments related to climate services currently, but I guess it's a debate to be aware of. I'm not sure if you could add anything, Marta, to.
Yeah, I could. I agree. I think from my experience, at least, and my understanding is that in general, seasonal forecasts, as they come out of the models and whatever is put out in terms of the big producers of seasonal forecasts, I think most of the times are not in itself useful. I think it requires a certain amount of work and efforts put into it to make it something that is actually useful and usable by the farmers at the local level, which is this kind of middle ground that Natalie was just alluding to, which is, this kind of bringing the two together, the local knowledge, their needs, the timings of when they need information, how they need it, even like the example that Natalie was saying about women in India preferring to receive the information via SMS because, watching the TV or listening to the radio does not fit with their day-to-day activities and the time they have. So I think there's, generally speaking, there is this need to bring the two together to make it something that is actually usable by a lot of people on the ground.
And I think as well, I'd just add something about trust in there. There's a level of trust about where that information is coming from. So if you're kind of a farmer in a village and all of a sudden you're getting this information that's just come from someone or somewhere, you're not quite sure where that's come from, then you might not be as receptive to that information as if someone had I guess, as Marta was saying, it's the way the information is distributed. So if you're receiving that information from somebody you trust, like a village representative who has connections to the local advisory service, then you're more likely to respond to that information. I think that's what the literature suggests as well.
Yeah, definitely. Yeah. I mean, in a lot of least developed countries, there's a lot of work with it through extension officers and things like that. So there's also these kind of networks and hierarchies of where the information travels and all of that, which, it's normally not about putting out a seasonal forecast and then the farmer goes and pick it up. There's a lot of kind of intermediary levels of interaction and work being done as well in between, and where a lot of these trust relationships lie as well. So, yeah. Sorry about that. I'm not entirely sure if we addressed your question.
No. Yeah. So I get it. So I think it's quite a complicated job, particularly in developing countries, because the agriculture there is more micro farming. So it's not like one big company taking over hectares of land. It's like every acre is owned by a separate person, and it's quite tedious task to somehow, get the information to these farmers.
Yeah, and like you said, Bala, I mean, a lot of, it's very risky for a lot of these people as well to be, to putting all of their trust and making decisions based on these type of information. So there's a lot of factors that go way beyond the quality of the forecast, if you see what I mean. A lot of trust is involved, a lot of the information fitting their needs and the time they receive it and how they receive it. All of these influences if they're going to use it or not, the information, and if it's usable to what they need to do.
And also, like, particularly with microfarming, they are basing their entire income on agriculture. So if the forecast goes wrong, it directly impacts their daily income, or, it's kind of very rough. Yeah.
I mean, we're talking about the main source of, for their livelihood. So yes, they don't take these kind of decisions lightly. So good. Thank you.
Yeah.
Thanks, Bala. Anyone else? Any questions before we pass on to the next speaker?
I have a question and a comment, if it's possible, but I don't know if there are any other questions from the other participants.
Not for now, so go ahead.
Yes, now I would come back to the example of the potential avoided losses by the ARRCC, the typhoon that you have presented before. I'm just asking if there are something similar also in terms of false alarm, for example. And here the idea is for 5 days, so it's more meteorological forecast than climate prevision. And I'm wondering if there are something similar even for the longer time scale, so in terms of seasonal forecast, and especially in terms of the false alarms, also in terms of the trustability of the service, because here it's quite plain and straightforward. I don't know if when you are looking at longer time scale, this issue could be addressed.
So I think you were asking two things. There was one about trustability of the information, and the other was about even longer time, or like longer projections that could result in a warning. So the second question relating to longer projections resulting in a warning is not something I'm aware of, but I'm not involved. I'm not a climate scientist. I don't do this kind of. I don't use this kind of data. So my focus would be on how that impacts people. So I'm not aware of that, but I don't know. Potentially, I don't know if Marta knows if that exists. I don't think it does. I don't think you could make those kind of projections, but potentially.
In terms of evaluation and using this particular method to understand the potential for calculating avoided losses on the back of weather and climate information. I think a lot of the literature and a lot of the studies we come across do focus on early warning systems. So there's not so much on the seasonal timescales, which is something Natalie and I picked up on the work we're doing in ARRCC, actually, that a lot of these examples come from the early warning systems, from disaster risk reduction efforts and all that. in terms of actually using this method to perhaps try and understand in a longer timescale, like seasonal, I think there are, I mean, I'm not entirely sure. I think there are challenges that we would have to overcome, including the fact that the reason why this example is so neat, it's because, you know, we're assessing avoided loss against a specific event that happened. Unfortunately, it was a cyclone that was massively, you know, destroyed livelihoods and killed people. So, but against that, it's easier to calculate, you know, avoided costs in relation to what happened, and against a scenario where you would have this kind of system in place. So in terms of seasonal forecast, as we know, that doesn't necessarily happen. We're not looking at, you know, extreme events or really, you know, disasters happening. It's a more of a gradual change. So I'm not entirely sure how effective this would be, this kind of method. Having said that, I think it's also about defining very well the kind of the phenomena you're looking at in terms of using the seasonal forecast and using this method. But again, it depends on well you are able to define what you're doing your analysis against. I'm not sure if I'm clear here, but I think it's more this. It's two things. One is having a specific event you want to analyze against, and in this case was the cyclone. In terms of seasonal forecast, that might be harder to, you know, pinpoint exactly. And the other one is the nature of the information itself. You know, seasonal forecasts, we're looking at longer timescales, probability forecasts, and all that, which also kind of, I think it might make a bit more complex doing these kind of things, analysis. But I don't think it is impossible. I just think it's about defining very clearly what you're looking at. Does this respond your? Sorry, Natalie.
Yeah. Yeah. Well. No, completely. Thank you, Natalie, and thank you, Marta.
I guess quickly, just coming back to that point on trustability or trust about the information again. So that's why the system works really well in Bangladesh, because people trust the government, they trust the information, and they respond to it. I mean, there's lots of reasons why people in Bangladesh don't always use cyclone shelters, but it's not necessarily related to trust in the information. So I suppose if you compare to the US, like Hurricane Katrina, there was a warning there, and there was lots of complex reasons why people didn't evacuate on time. But one of those reasons was because there just wasn't that same trust in the government and in the information. And I suppose looking at somewhere like Cuba, that there's massive trust in the government, and there's that really different relationship between the people and the government. So they have a hurricane warning system in Cuba, which is really advanced, and they have every year they have a hurricane drill where everybody knows their exact role they have to play, and they follow that. They have a warning, and that they follow what they have to do every year, and they move all their equipment, everything, and evacuate to where they need to go, and that's part of building trust in the government and in the information. So again, yes, I think it comes down to not just what the information is, but but trust in the information as well.
Okay, good. If there's no other quick questions, because we're now running late, I would thank again Natalie for the really interesting presentation, and I will introduce the next speaker, which is looking like he's ready to talk. So the next speaker is Federico Caboni. He's co-founder and R&D director of B2B, which is a software company, and has been involved in ICT in various capacities. I'm not going to tell you all of the capacities, but he's been involved in a lot of things: system architecture, project management, researcher, developer, and so on. Engineering, multimedia, enterprise, cloud service space for more than 20 years. So he's basically your guy in terms of how we want to think about this kind of implementation of the climate services. So I'll pass on the floor to Federico whenever you're ready.
Okay, can you see my screen?
Yes.
Fantastic, because I'm using two screens and I was not sure how time would react to such complexity. So first of all, as Marta said, I've got an ICT background, and I know people from ICT tend to use our jargon, our technical lingo a lot to throw around terms and details and languages and technologies. I will try to avoid all of that during this presentation, and because I decided it was more important to focus over the process, to focus on the challenges that we found in implementing a climate service for this project. But of course, if any of you want to dive deep into details and ask me technical questions, I will be more than happy to comply. So, our role in the MedGold project is that of building and managing the ICT platform. This is actually a very early representation of the platform from the first period of a few years ago. Nowadays, this kind of drawing will have maybe 5 times as many little boxes and stuff. But the important question is why? Why do we need this level of complexity to do things? Okay, let's go back to what we are trying to achieve with this project. This is straight from our homepage, our site. We want to turn climate-related information into added value, which means 2 things. First of all, climate-related information is already available, as you know, because you have worked a lot, I think, with data straight from the CDS during the Living Lab. And the second point is that you need to do some work to turn this information into added value for these 3 crop systems. How does this work? Well, during the project, basically, I think, and I've seen that you have been exposed to a lot of the process, a lot of the tasks we've been doing during the project and involvement with users. And but basically, from a very simple-minded point of view, coming from an ICT expert, it's a bunch of people working with their computers, which I think is pretty much what you did during your Living Lab. Maybe you collaborated together in some way, you shared files by email, maybe by Git, but basically it's a bunch of people working on their own computers. And this is basically how it works during the research phase of the project as well. Maybe Sandro is working on setting up the downscaling algorithm for some data set, and Alessandro is doing another thing, and Marta another thing, which is okay because it works well. It's the way we all are used to work. But the equation changes a lot when we take into consideration we are trying to make a service. A service implies users, and if this service hopefully is successful, there are a lot of users. Of course, a bunch of people with their laptops want to do. If you want to serve climate information or rather products based on that information to a lot of users, you've got an issue of scalability. The scalability is not necessarily related to ICT systems, even if it's, of course, a very important term in ICT. It's just the capability of a given system to handle a growing amount of work by adding more resources. You can consider the scalability of a system of whatever process you can think of. For example, let's say you want water, okay, to drink in your house. The simplest thing, the thing you can think of is just grabbing a bucket, going to the nearest well or river, whatever, filling it with water, bring it home, maybe boil it if you're not sure of the purity of the water you've taken, and store it somewhere, maybe put a cloth on it so it won't get rid with impurities. So far, so good. But what if you need to provide water to an entire city? It's quite clear that a bunch of buckets is not the solutions, because you would have thousands of persons around the world fighting for access, and a lot of wasted effort and resources, because you will need to bring them along with, I don't know, trucks or something like that. So the bucket as a water delivery system is not very scalable. So what do? This is basically what we do, piping. And this is very interesting to notice that this is much, much, much more complex and complicated than this. Because when you need to scale, you need an infrastructure. You need to build an infrastructure. You need to maintain it and to design it within certain parameters and certain logic. It's much more complex. It's not just a matter of having a bigger bucket. You just scale in complexity as well. So let's go back with ECT, because actually it turns out data is not very dissimilar to water in this respect. We've got different kinds of scalability. The simpler one is the vertical scalability, which means you just get a stronger, better computer, more RAM, more CPU power, and a better GPU, whatever you need for the task at hand. If you're a gamer, if some of you like playing games with computer, you know vertical scalability very well, because given game won't work with my computer. I just add a more powerful GPU, which is good because you don't need to change the game itself. You don't need to change the application to scale vertically. It's very simple, but it is very limited because you can only go so far adding power. There is an upper bound, and it gets exponentially more expensive to do. So the way you actually do scalability is so-called horizontal scalability, which means distributing the computing and the networking and the processing load between multiple systems. So you have all the details about clustering, about how to make those systems talk together and work together towards a common goal. And so we are making stuff even more complicated because now there is communication involved within those computers, unlike this case or your laptop's case. And well, communication between computers is much more easier to do than it is within humans, of course, but still, there are a lot of details and a lot of things to be taken into account. And the most important point is that the application itself must be changed because the application must run in different computers at the same time. So you have to partition the input and a lot of technical details I want to go into now. But the general idea is that horizontal scalability is the way to go if you really want to scale to a lot of users, but it implies even more complexity and even more technical tasks to do. Also, scaling horizontally by adding more computers, so making it distributed, also takes care of other problems we have, like high availability, which means we do want our climate service to be available always, not just 2 hours a day, because for the rest of the time is not working. So fault tolerance, what if one of those computers just takes, just stop working, and so on and so forth. So this is the general idea of having a scalable system. That's why we need this complexity. We need infrastructure to make this scale to the amount of user we will hopefully have. From a functional point of view, we are doing something that is very similar to a pipe. In fact, in ICT, this is called a data pipeline. We just take the data from the source. Actually, there should be another maybe box here, or at least an arrow. We take data from CDS, but not only from CDS, from a variety of sources. We store it into the system, we process it because we do need to do validation, we need to do format conversion, and so on and so forth. We do some computing, so maybe we calculate indices, risk indices, or something else that's useful for the problem at hand, and then we export. So we give the results of our work to the stakeholders, hoping they will bring some value to them. And so so far, so good. This is, in a nutshell, the problem of technical scalability, and a lot of our work within the project is, of course, related to that. There are a lot of technical details, but this is not the whole picture. There is another kind of scalability that is no less important, and that I call functional scalability. What do I mean? Let's go back to what we are trying to achieve. Turning climate-related information into added value. Well, the interesting thing with value is that it's a different thing for different people. Let's try to imagine three personas or three typical stakeholders that might be interested in using MedGold's climate service. Just an example out of hundreds of possibilities. So we've got a farmer in Tuscany, a policymaker in Germany, and a winemaker in France. Do you think that they will share the idea of value? Do you think they will be able to extract value from the same thing? I don't think so, because first of all, they're in different geographical regions, but that's simple. But also, they do have different time scales to take into account. The policymaker, for instance, will probably need to think about a larger time scale than the farmer. Maybe the winemaker would need something to integrate with her business intelligence system, because if she works she's got to work in enterprise, she will have to take into account not only the climate information, but financial data, economic data, logistics data, and so on and so forth. So the tool that will be useful for Sofia, the product that will be useful for Sofia, probably not so much for Angela. Maybe she will need something graphical and higher level to look at larger time scales. So our pipeline metaphor only goes so far, because after you go into the water processing stage, you take the water or data, you process it, you validate it, you do whatever you need to do with water or data to make it safe for consumption. Once you put it in the pipes, the tubes, well, water goes out from the other end. There is not much variability of how it can work. So maybe we need to introduce a new metaphor, which is the highway. The highway, in principle, is a thing that is made to allow you to go fast, hopefully, from point A to point B. But actually, most people don't use it for that. Most people take the highway and go from point A to point C, C being somewhere between A and B. So, in other words, a highway has multiple exits, like this one to Ausfahrt, apparently. And you couldn't say this particular exit is less useful than the end of the highway. So each exit, each particular, even if you use the highway for a little while and not from beginning to end, it has value for you. So this is the kind of schema we decided to use for MedGold. So if we go for the MedGold ICT platform, so if we go back to our pipeline, what we do is we implemented exits to every step of the pipeline. So, for example, you just need the storage, you just need to take advantage of the fact that we know how to find data from the CDS and other sources, normalize it, sanitize it, and convert it, and maybe cut it in smaller geographical entities. You can access the files from the ICT platform. So first exit has value for a certain kind of people who just need the files. On the other hand, we have the dashboard, which I think you have seen or used during the Legal Lab, which is you're just taking the highway from beginning to end, because the data is retrieved from the CDS, is stored, is processed, some indices are computed, and then you also get the visualization tool. So this is what I mean I meant for functional scalability. In order to provide value, oh, sorry, my computer is not as fast as my finger. In order to provide value to a larger possible group of stakeholders, we needed to, sorry, I'm not very good with PowerPoint, as it seems. We needed to implement a system that, of course, scales, so it can actually support thousands of users at the same time without failing, being available, and so on and so forth. But also, we need a kind of system that is pretty flexible with where a user can access. So we've got the files, so we've got the dashboard, which is quite the end of the pipeline, and we've got the API, which is a machine-to-machine kind of thing. It's a tube that you can use to connect the ICT platform, the climate service, to your business intelligence tool. For instance, you make computer talk, and they will pass that around, which is another way to extract value from the whole process that's happening in that world. So I think that's about it with my presentation. So if anything has questions, even technical or high level.
Thanks. Thank you, Federico. Are there any questions from the audience? Thanks for the presentation, Federico. That was really good. And I only understand half of it, but it sounds very complicated. And you're obviously very good at what you do.
Thank you. As I said, I tried not to go into details because it was not the point here. But if any one of you want to know about technologies, I'm here.
Yeah, I think your presentation is really interesting. You know, I think all the presentations in the Living Lab helps to understand how complex climate services are and what is required, and the kind of expertise that the multidisciplinary expertise that is required to actually make these things work on the ground. But yeah, if anyone has any questions to Federico, please do. Otherwise, we'll move to our next speaker of this morning. No, I think you just dazzle them with your, with your expertise, Federico.
I was either super clear or completely useless. It's up to you to decide.
Let's go with the first one. It was amazing. No, it was very clear. Thank you. So our final speaker of this morning is Michael Sanderson from the Met Office. And he will be talking a bit about how we can think about upscaling the more technical aspects of the climate services. And this related with the technical information in terms of climate information. So Michael is a senior applied scientist at the Met Office. He translates climate information into products for a range of customers, such as infrastructure operators, providers, and health professionals. He led Work Package 1 in the Medical project, where various observational and model-based data sets were assessed for using in the development of climate services for the three staple crops that we look at in the project. So without further ado, Mike, are your slides working now, or you still need Alessandro to go through them? Oh no, it's Alessandro doing it, right?
Okay. Alessandro's going to run the slides for me, yes, because I'm having some issues at my end here. Okay, can we next slide, please, Alessandro? Yes, here's a brief summary of my talk then. So I'm going to very briefly talk about what are climate services, perhaps with a more technical slant. Think about how the users would access a service when they're upscaled. Think about what sort of data are required to enable the upscaling, and then sort of perhaps relate to what Federico's talked about, is trying to make the service more operational and less of a sort of something that doesn't require a lot of manual intervention. Next slide, please. So briefly, what are climate services? Well, if you look in the literature, there's many different definitions. So I've just chosen a couple here. So the European Commission have one, simply the transformation of climate-related data into customized products. which is quite good from sort of the technical side of things. And another one I've seen is operations required to translate climate data into a climate message and decisions or policy. So they're sort of quite useful ones when considering the upscaling of climate services from a pilot to something more operational for multiple users. So next slide, please. So what type of service would be provided then? So when the service is upscaled, so would it be a broad or a deep one as defined in this paper here? So a broad service would be more of a mainstream one that would have many different users there, but perhaps a simpler set of products to satisfy the needs of those users. Or of course, it could be what's termed a deep one. So it'd be much more specific type of service in the things it provides, but that would only be perhaps applicable to small numbers of users or even a very specific type of users. And it's also important to remember, we certainly found this in the Met Office in some instances, the pilot service is naturally developed with a smaller number of users than perhaps the ultimate number you'd like to reach. And sometimes that response to that small group can be biased and perhaps don't necessarily represent the wider pool of users you want to get to. So that's something to think about when upscaling the service to a much bigger number of users. The sort of pilot group may not necessarily represent the much wider potential users you might want to access and assist. Next slide, please. So how can the users access these services? Well, there's many ways, of course, and depending on where they are and what level of sort of technology they have access to. So one example would be, of course, a web portal, perhaps like the MedGoal dashboard. But other users, they may not have access to a computer or even be willing to for whatever reason. So the only thing they might have on them readily is a smartphone. So however the users access it, it needs to be support these different platforms here. So maybe a simple app is the only way certain users could be reached, especially in very remote regions. So that's something to think about, how the sort of the interface works to let the users access their required information. And it's also to think about how should the service be provided. So there's potentially 3 levels of sophistication here. So the first one, well, I've termed predetermined maps. So I was involved in a project that finished some years ago called AgriClass, where we created maps of key bioclimatic indicators for certain sets of users, but they were all fixed. So the time periods and the type of information was fixed. So the user could look at different maps, they could look at the effects of climate change and different time intervals, but that's all they could do. And a sort of example of something similar is this sea level rise tool here. So if you just press the button, Alessandro, an image should appear. Yes, here we are. So this is a screenshot from the sea level rise tool. So this is looking at sea level rise projections for islands in the Caribbean. So across the top here, you can see 3 sample islands that a user could look at and 4 different scenarios. And then depending on what they click on, a graph like this will appear. So it shows the sort of median sea level rise estimate from the dots there, and then there's 2 uncertainty levels which the users can look at depending on how risk averse they are. And the black line there is annual mean sea levels from a nearby tide gauge. So it's just to sort of sense check that the projections are doing the right type of thing. And what you can't see below here, if the users want to, they can get the actual raw numbers that this graph was created from if they so desired. So this is a very simple interface, and these graphs were all created by a data scientist at the National Oceanography Centre in the UK. But if it was decided to upscale this, say to many, many more islands in the Caribbean, maybe different locations on those islands, different scenarios and so on, clearly the number of graphs to create is going to rise very rapidly and probably be unmanageable. So the next option then is to have a service that's what I call predetermined calculations, which is an example of that would be the UKCP18 interface. So that's the United Kingdom Climate Projections 2018. So if you press down again, Alessandra, another image should appear. Yeah, so this is like the front page of it. So when you go on to if you sign up for the UKCP interface, the first thing you get is this list of all the different climate projections on the left there. So there's global projections, regional climate model projections, what we call convection permitting, which is the 2.2 kilometer simulations. There's different scenarios, some of which may or may not be available, depending on which climate data set you're interested in. And there's different time periods, and then you can also look at absolute values or anomalies. And the idea is then, and then again, you can create maps of the data, or you can create time series like the plume plots show there. So the idea is a user will then choose this relevant option, submit a request, which will give you a screen with various radar buttons on or drop-down boxes to choose. And then when the user selected all the different options they want, again, and there's other things in there like area averaging, so you can look at changes from an individual model grid box all the way up to an average over the entire UK, in this case with various steps in between. So once the user submitted their request and selected all their options, the job is then queued on a server. It's usually quite quick, but then the user receives, when it's all finished, the user would receive an email. So Alessandra, if you press the button again. So something like this would appear. So when the user receives an email telling them their job is finished, they click on a particular link in that email, and that brings up something like this. So in the bottom left there, you can see the image. So I selected average temperature change over southeast England. I know the lines are hard to see, but there's 12 lines there from 12 different regional climate model simulations. And then the users can download the raw data in 2 different formats and download the image as well. So I should say all of the different ways of manipulating the data were agreed with lots of different users through a series of workshops, a bit like the sort of things that have been going on in MedGold. So the way this works is all of the raw data from the UKCP 18 projections are stored on a server. So none of these products are stored, and then they're just calculated on request when a user wants them. So although the users can do lots of things, the types of calculations are sort of now fixed, although in theory it would be possible to add extra analyses. I don't know how easy that would be to do in practice. So there's one more level of sophistication. So if you go next slide, please, Alessandro. And again, is to let users do their own calculations. So one example of that is the Copernicus Climate Data Store. So if you go on to the next slide, please, Alessandro. That's it. So this one thing this has, I haven't used it myself, but I know it's there, is this toolbox. So the idea is users can then write their own programs, or perhaps copy and modify other programs to do their own analysis, and they can store the results from intermediate steps and do all their analysis on the CDS server, and then just download their results. So if users really wanted something specific and they had the technical know-how, this method will actually let them do their own custom analysis of the data. So that's 3 different steps of a user interface there, from sort of just providing simple maps to a sort of wide set of predetermined calculations, to giving users essentially the freedom to, within some limits, obviously doing whatever they want with the data. So that would need to be considered in the upscaling as to what level of sophistication is required. So next slide, please. And then one needs to think about which variables would be supplied when upscaling. It could be simple things like essential climate variables, temperature, rainfall. Is it going to be sector-specific indicators like spring rainfall and things along those lines? Is it going to be something requiring more sophisticated models like levels of pest infestations or crop yields, quality, and so on? Or would it be something broader scale? So one thing we developed in the Met Office a few years ago for the transport sector was this impact metric based on our seasonal forecast for winter. So this was just a simple metric to predict potential levels of disruption from bad weather, depending on whether the forecast was for a mild and wet winter or for a cold, snowy and icy one. So again, what sort of variables the users are interested in when we're upscaling, because again, that would affect what data required to create some of these different type information on this screen here. Could we go on to the next slide, please? So again, how far should the service go? So one of the aims of MedGold, as Federico showed, is to provide climate services for the 3 key Mediterranean crops, but there's only so far MedGold could go there. It may not be possible. In fact, generally, climate services cannot necessarily address every single request from users. So what to do? So one method is to stimulate third parties, get other people involved, data brokers, private companies, independent consultants who perhaps could take the raw, take the climate data from the service and then go on further to develop quite specific solutions for certain users, or local solution for certain users that might be beyond the sort of realms of what's possible for the broader project there. So one example for this might be in Medgold, the company Easy2See, who have developed a sophisticated model for predicting olive fruit fly infestations. So it probably wouldn't be sensible to try to create something like that from scratch for the Medgold, but Easy2See can take the data provided here and then run their model through it to provide that sort of specific product for users. Next slide, please. So again, if we're going to upscale to perhaps different areas and different types of users, we may actually need data from those users to check the models. So if you want to check the yield predictions are correct or levels of pest infestations, we would probably need the user's own data on that as a way to check that what we're providing is actually useful and applicable to those locations there. I'll ignore the next bit there. Could you go on to the next slide, Alessandro? So yes, so and then there's also the question of making the climate service operational. Once we have a pilot developed, the next thing to do is make that more operational. So there's much less manual intervention required. And when that needs to be done, the service first of all needs to be timely. So if it uses things like seasonal forecasts, it needs a way of ingesting new seasonal forecasts when they're created and recreating the product sort of quickly and alerting the users. Otherwise, if it's too slow, it's no use. And it needs to be accessible. I've already talked about that. So to everybody, so especially those in remote areas who may only have a smartphone, they may not have access to a computer. So how can these different people with different sort of physical hardware access the services? And of course, it needs to be reliable in the way Federico's already talked about. Next slide, please. And then there's the other issue of, once it is operational, who's going to host it and who's going to pay for it? Because also there will be overhead, there'll be a physical server will have to be operated. That will need technical support to keep it up and running. It will need, say, software, of course, to ingest new seasonal observational data when they become available. And it also needs to be, in a way, more resilient, because when new versions of seasonal forecast models, for instance, are created, they often have higher resolutions than the old ones. So the climate service would need to be able to cope with changes like that. It may have knock-on effects, such as changes in locations of skill. One would hope the skill would generally improve, but it's possible in some places it might actually go down, which might impact on some users. So that's things to be aware of when operational and new models or things become available there. Next slide, please. So again, yes, one of the things that's very important when upscaling is an assessment of model skill. So that's really important, whether it's a forecast or a climate projection, because model skill, any model, or whether it's a climate model or a seasonal forecast, does vary spatially and temporally. So for example, in Northwestern Europe, the seasonal forecast skill tends to be highest in winter but poor in the summer months, whereas some other models do have some skill, let's say, over the Mediterranean during summer, but not over Northern Europe. So Alessandro, if you click the button, an image should appear. Yes, so this is an assessment of skill of one seasonal forecast system that was made. So this is predictions of summer temperatures, and generally the more red the color is, the better the skill. So you can see, if you look in the Mediterranean, all of these three models shown here actually have quite reasonable skill, but they don't really have any skill over Northwest Europe and the UK. You can see the area is white there, so models have no skill there. So though, for example, for vines, we know we have lots of wine growing in Portugal, so the service would work there, but there are a few vine growers in the UK. And if we wanted to upscale this to other areas, this service couldn't be provided for the UK because the models just don't have any skill there. So that's something else to think about when upscaling is it physically possible to upscale to certain other areas. So that's why this skill assessment is really important. If you go on to the next slide, Alessandro. Yeah, one more, I'll skip over that. One more. Yeah. So just to say, we can't really upscale to areas with poor skill there. So next slide, please. And then let's also think about observations. These are needed to verify model forecasts, test the skill, compare model and observe trends, and lots of other different things there. Then the question is then whether to use gridded data sets or local observations. So gridded data sets are derived from local observations, but one question to ask is how frequently are they updated? So the EOBS data set, which is a Europe-wide gridded data set, and that's updated roughly once a year. So that's quite good. Now in MedGold, we've used these two other data sets called, so the first one, PTH rose, is for Portugal, and the next one is for Spain. And these are much higher resolution, they're around 1 kilometre. But the only issue with them at the moment is they end in 2015. And as far as I can see, they haven't been updated, and I don't know if they will. So as we go further and further ahead in time, these data sets will become more and more out of date, which might be an issue. And again, this is a particular problem. This other gridded data set we use called Admera, because that ended in 2010 and has never been updated. And then there's also another thing to think about with gridded data sets is they sometimes change resolution. So EOBS was originally around 25 kilometers, but currently it's now down to 11. So if that happened again to a higher resolution, that was ingested again, that was something an operational service would have to be sort of take into account, that the resolution may change, that may change the appearance of some products and things like that. Next slide, please. So yes, just a brief summary then. So there's clear need to upscale climate services from a pilot, so they can reach a much wider range of users, but there's lots of issues doing that. So the first thing is making the service operational, so it requires much less manual intervention. And then think about what is the complexity of the user interface? Should it be simple maps all the way up to something that allows users to do their own analysis? What sort of level of complexity is required? But regardless of that, it needs to be accessible and it needs to be timely. So it needs to ingest new information when it becomes available quickly and alert the users, and reliable, as Federico described earlier. Needs to be thought about who's going to host the service and pay for it and maintain it once it's sort of ready to go operational. There's also needs to think about the role of third parties. So if there's something certain types of users need that a project couldn't create, then it'd be sensible to involve third parties who could develop those bespoke solutions for certain types of users. And again, as I said here, that when new observations of forecast data are available, it's important perhaps that the service is capable of ingesting those, so it's using the newest and best data available to give the users the best service. So I'll stop there and take any questions.
Thank you, Michael. That was very good. Any questions from participants? No? Okay, well, you can always email Mike or contact him via Chime, I suppose. Okay, so if we're all ready to move on, and I think we're a bit late, so I'll just go into the next session, which is me, actually, and it's about feedback from you guys. So I'm assuming you can all see my screen. And this is very quickly, which is we need to understand, I mean, it's the first time we're running this living lab. I mean, this, as you all know, this originally was supposed to be a face-to-face summer school in Italy. However, given the circumstances, we had to quickly adapt and restructure this as a living lab and an online living lab, which poses its specific challenges and limitations. And as a result, we are very keen to understand if this has worked for people, if it didn't work, and as a result, we put together this feedback form, and the link is there. I'll share it also I'll share it now. Sorry, whilst I'm doing this, so we can all you guys can start filling in if you want to, because ideally I would like to collect this feedback now. So I'll put it in the general in the general chat, but also in the coordination chat. So coming back to it, feel free to start filling in if you want. I just wanted to provide you the link. So this feedback form hopefully takes you 5 minutes. It's about a bunch of questions about the living lab, what did work, what didn't work for you guys. And the main aim is to help us improve how we do this next year. I mean, we're not sure if next year we'll be able to run the summer school face-to-face or if we need to do this again, this kind of online living lab. So it would be really, really important to have your feedback to help us do this better next year. The responses will be anonymous, so it's up to you if you want to include your name or not in it. But what I mean by being anonymous here is anything that comes out of this, reports you might put together for the European Commission on this living lab, your names will be totally anonymous. So that's what we mean by being anonymous here. So, but it's up to you if you want to tell us your name and who are you when you fill the feedback form. What is really important for us is for you to be honest and critical. I think it is important and we can take it, so don't worry about us. What else? If you change your mind and you don't want to be part of this, just let me know in the next couple of weeks and I'll remove your responses from the survey. So this should take 5 minutes to fill in, and I would really appreciate if you could do it now, because if we leave this for later in the day or some other day, you might never do it. So I want to take this opportunity and be a bit fascist about this, and I would really ask you to do this. And this only applies for the participants, not for the coordinators or the mentors, so, or the presenters. So don't fill it in, okay? You guys can just go and grab a coffee, whatever. If you have any questions or if things don't work for you, let me know and I'll try and make this work. And again, thanks for helping us with this. It is really very much appreciated. So I'll leave it there. And it's fine. And I can see now if there are people already filling it in. You can also see my screen. I can actually stop sharing my screen because you don't need to see what I'm doing. I can show my dog for those who are not filling in the, yes?
So we can reconvene in 5 minutes after the feedback, is it right?
Yeah, sorry, yes, okay. So you're right. So because after the feedback, we were having a coffee break. I can't remember now because the agenda changed. Let me just check.
Maybe now it's time for, after the feedback, to have the comfort break before the presentation of the first team.
Okay, so should we say, 10 minutes?
Yeah. Okay.
Comfort break plus survey. It's not survey, the feedback form. Yeah?
Okay.
Okay. So I'll see you soon.